All right, so today we're going to go back to the first topic of the phase of the mod, object-oriented programming, after which I'll talk about the different ways you can incorporate functions into your project. And I have that sample project that I've been showing you all, my old project, and just showing you how you can make your notebooks a little more organized by putting your functions in scripts. All right, so just a quick intro to object-oriented programming. I will say that quite unlikely for a data scientist, you're not likely to be asked to do anything object-oriented programming related. But it's always good to just be aware and to know, and maybe you find this useful and maybe you want to incorporate this into your projects. But so far, what we've learned to do is we're actually creating objects from the built-in classes that are provided by Python. So we have been using classes, and whenever you hear object-oriented programming, it's usually talking about classes, and we'll define a couple classes later on. So everything, including strings, integers, lists, these are all classes, and these are all objects that belong to their respective classes. So in addition, we've organized our programs into functions that help you process and manipulate our data. Not just the defining of functions, but also we're using methods, which are kind of like functions as well. So this style of programming is known as procedural programming. Now what we're going to do is talk about object-oriented programming, which is a different style of programming, which allows you to create your own objects and procedures from classes that you can design. So object-oriented programming is useful because it overall speeds up development and makes your code more reusable. And again, through the examples, we'll look and see how that is. So for some terminology to begin, imagine this human is a class, human class. You sort of think as the human race is a class. Objects, each person is an object within the class of humans. And then each person, each object has properties. For example, every person has an email, has an address, perhaps even like a height, weight. Those are all considered properties or attributes. And then each person also has methods. Each person can do or perform a function. For example, this person verifies and also sends mail. So these are the person's methods. So within a class, you can create objects, and objects have properties and methods. So those are the main pieces of terminology we'll be using. So technically, Python is an object-oriented programming language because everything is actually stored as objects. I think if you remember in the past, if you have like a map lambda something, so let's just see a quick example. If I do this on a list of 1, 2, 3, you end up with like some sort of map object. And it's not until we coerce it into a list that we can actually see what that object is. But without this list, you can be certain that the information is still there. It's just presented to us as this map object. And what this is actually the hash key for the location in memory of this object. So that's kind of what that means. And let's just go back to the idea of a function first. Function is an abstraction where an algorithm is made repeatable. So we've written functions since mod 1. So instead of coding something like this, where if you're doing a repeated process over and over again, you can do it in a for loop as well. Instead of doing either of these, it's arguably more straightforward to just create a function to do this. So whatever you want to do to square add 10, we can just plug in any number, and this function just becomes reusable. So that is the benefit of writing functions. So before, creating a function was about making a certain algorithm available to any input, right? Or different inputs that the function can be used on. Now I want to make the function available to different objects. So this is where we get out of this further abstraction. Each object is an instance of a class. So I'm going to break down these technical terms. Each object is an instance of a class is synonymous to each person being an instance of the human race. So each person being an instance of the human race is the same as each object being an instance of a class, and we'll instantiate some objects later. And each object defines attributes and functions. So with this example here, each object is a person, and the person does come with a bunch of defined properties and methods, which are attributes as function. So now it's proprietary object type called methods. So every object of the class automatically has these attributes and methods. And when you're designing your own classes to create your own objects, you can actually define these things as well and edit these as well. So we'll have some examples walking through these. So when we say that everything in Python is an object, we really mean that everything is an object. So even attributes and methods of objects are themselves objects with their own information. So consider just this x equals to 3. By setting x equal to an integer, x is not just going to be equal to 3, right? X also will now have all of the attributes of an integer and it can use all the methods that an integer can use. So I guess to make it more concrete, let's do a data frame. And I think an empty data frame would work. Oh, import pandas. All right, so when we set df to be a data frame, df will have all of the attributes of the data frame and all the methods of the data frame, right? Because remember, you can do df.shape. So df.shape, and we'll actually look at how that the difference between having the bracket, the parentheses and no parentheses actually comes into play here. df.shape is the attribute of the data frame that df is learning just by assigning a data frame to df. And you can also use all your methods, like your .info is a method, and these methods and those attributes like .info, .shape, anything that you can do at the end of like a data frame, those are all things that were defined with the data frame class. So questions about that so far? Cool. So just to recap what I just went through, by setting x equal to an integer, you're imbuing x with the attributes of the integer class. So the type of data that an object can store of the integer class, and methods of the integer class. So the tasks that an object can perform. So I guess with an integer, we haven't really played around too much with like the attributes and methods of integers. I honestly am not very familiar with them either because we don't use them a lot. But we can use the example of data frames to see that anything that you do, a .info, a .describe, a .shape, .head, these are all, anything with the parentheses is a method, and anything without the parentheses is an attribute. And so that's how, we have these random like variables that we set. That's how we can use these methods and attributes. That's how we can get the attributes and use the methods, because you're storing not just, the data frame, but also everything that a data frame can do to that variable. And so this example was already here. Apparently, well, no, integers do have a bit length method that will tell you the bit length of the integer. So you can see the integer being 3, the bit length is 2. I think if I make the integer a much bigger number, you have a bit length of 22. So it's just in bits how long it is. How much memory does it take up, I believe. Questions so far? I will also say this is a very, very different way of thinking about programming than what we're used to. So it does take a little bit of getting used to. I will say, I believe Codecademy, I don't know if it's still free, but when I was doing it, it was free. Codecademy's Python course does walk through a lot of object-oriented programming. So if you're interested in getting more practice, I think that's a pretty good resource. I will look and see what other resources are available that are free. So all right.
So just to like reiterate, so wait, so the data frame, like the DF, would that be considered a class?
So data frame itself is a class.
Okay, yeah.
Right, so now, but then pd.dataframe, when you've created this data frame, DF is now an object, which is an instance of the data frame class.
Okay, gotcha. And then that's why you can do like the different methods, because it's an object and it's all tied into that.
That's right. Yeah.
Okay.
Yeah.
And is there any like like often when I do df.shape, I put the parentheses on and like, oh, I shouldn't have that on. Is there any way to kind of know what is an attribute and what is a method?
Honestly, documentation would be the way. Another thing that I'm not sure if I've mentioned it to you all, but have I said anything about tab completion or shift tab? If I haven't, I'll talk about it right now. Let's say we have this data frame that we've already assigned here. I believe if you do shift tab, so shift tab will show you like what this thing is. As long as your cursor is within that variable, shift tab gives you like a quick summary of what it is. And I think if you do like a dot and then you click tab, there we go. If you do, so what I did here is I typed in the period and I pressed tab, I can basically see like all the different methods that the data frame can use. So for example, ones that we know dot shape, and let's click on dot shape over here. It does that. Let me see if it works with method. I personally don't use this a lot because I prefer just looking it up and finding documentation, but this might come in handy for some of you. .info, so I guess it doesn't do it automatically, but anytime you see like bound method .info, you know, sometimes if you don't remember the parentheses, that comes up because it's a method, you want to have the parentheses there. But you can see that there are 0 entries here. But yeah, unfortunately, there's no way to just know right off the bat what attributes it has, unless you know you're the one that defined the class and you would just know. And we'll actually walk through like defining those things. But yeah, unfortunately, it's more about like reading documentation. The tab complete might help as well. But also like just getting used to seeing these errors. I think this is something that like there are certain functions that I still like make this mistake with. Like if I do that shape, I believe you'll see something about like attribute not callable because you're trying to call whenever you have the parentheses there. But yeah, usually if you see an error, it's probably like get rid of the parentheses or put the parentheses back. But yeah, it is not very clear unless you look up documentation. All right, any other questions so far? Cool. So again, just another way of putting it, an object is an entity that contains data along with associated metadata or functionality. So again, your attributes and your methods. In Python, everything is an object, so every entity has the metadata or attributes and also associated functionality called methods. So these attributes and methods are accessed via the dot syntax. So, you know, when I do like dot shape or dot info. So I like to think of OOP's use of objects and classes like a blueprint. So when you have a class, and let's say this class is car, you can create these objects out of this class car. And then imagine like cars to be data frames. So depending on what you do to each object, you have different like dot shape results. So let's say Mercedes dot shape will be different from BMW dot shape, which is different from Audi dot shape, for example. But likely all of them are able to use their method. So like the dot info, even though, you know, these are 3 different cars, you can use the dot info method on them to get like the information about the car. Just an abstract example. Questions so far? I will tell you all that when I was a student, OOP was taught at the very beginning of Mod 1, and I thought I was never gonna code ever again. So it's very hard to pick up, at least in my opinion. I think probably easier to pick up after you've had some experience, like just coding and functions, but yeah, it's definitely like a weird concept to get around, I think. All right, so yeah.
Oh, sorry. The methods that you call upon, so they're basically just like hard written functions that come in the package, right?
Yeah, that's right. That's right. So every package is actually defined as a class, which we'll actually walk through right now. Yeah. So cool. Yeah. Any other questions before I move on into like actually coding out a class? Awesome. So to create a class, all you have to do is just start. It's very similar syntax to like defining a function, I guess, where you have like instead of def, it says class. And then you name your class, and what's the word? Like the names of classes are always in upper camel case. And what upper camel case means, it's always starts with a capital letter, and then every new word is capitalized. So upper camel case. For those of you who are curious, regular camel case is just, it always starts with a lowercase letter, and then every time there's a new word, it's capitalized. But that's called camel case. I think it's because like having the capital letters in the middle creates like humps like camels. But yeah, so you can create a blank class. And so we're gonna just walk through different processes of creating different robot objects. And we're gonna have, we're gonna see if robots can have different attributes. So we're gonna see if robots can have methods, like things that robots can do. That's what we're gonna build. So first, let's just build like a super basic class. Literally, we're literally not defining anything, but we're gonna say that robot's gonna be some class. And under it, we're not gonna do anything yet. So let's just start it off with pass. But once you've defined this robot class, you can already instantiate robot objects. I have it all in one cell here, so I'm just gonna run it real quick, but I'm also gonna break it down. So first, this first line that we had here, my robot equals to robot parentheses, should look kind of familiar because it's exactly what we're doing when we're instantiating models in scikit-learn. So remember how we're doing, like, for example, like linreg equals to like linear regression. With that, it's instantiating a linear regression object. And what we're doing with like all these scikit-learn models is with a linear regression object, we're then fitting the data to it. So it's learning new, it's learning the right coefficients for the model. And that's like basically editing the object and adding to the object. So that's what we're doing. That's how like object-oriented programming ties back into our modeling process. Anyways, this step instantiates the object. So my robot equals to robot, and we can actually take a look and see what that is. Right now it says that we've actually made a robot object at this location in memory, which is pretty cool. We've made a robot. So in here, we don't say exactly what attributes a robot has. So within this definition of the class, these robots can pretty much be anything they want. Therefore, you can just create new attributes. So for example, here what we're doing in these two lines is we're saying, all right, let's make the robot's name. So when it's an attribute, remember with attributes, there are no parentheses. We're setting the name of the robot to be Wally and the height of the robot to be 100, apparently in centimeters. So I've already run this. So you can access these things just by doing myrobot.name. You can see, oops, did I not run this already? I don't think so. Let's double check. Oh, right, because I redid that one. All right, so when I do myrobot.name, you can see you get Wally in the exact same way when you do like df.shape, you get the shape. I can also do myrobot.height and get 100. And similar for your robot. So just as an example to show your robot.height, which is done here, 200. So the robots live. You can see that we're printing myrobot.name, myrobot.height, and then same with the other one. All of this now exists somewhere in memory. So let's say you want to give, oh, yes.
Hey, I just had a question. So like, let's say you make another robot, like just iRobot, I guess. Mm-hmm. Will it automatically think that it should have those two attributes? Like, is that broadcasted for the whole, every object for the class, or is it?
Yeah, that's a great question. So if you want something to like know what attributes to have, you would actually define it under the class, and we'll actually do that next. But because this definition of the class doesn't have that, currently it doesn't know what attributes to have until you like literally create them.
Okay, gotcha.
Mm-hmm. So for example, let's say we want robots to have a purpose. Right now, it still has no robot purpose. Of course, you can do like you can literally set my robot.purpose equals to protect humans. And then that will give it that attribute. But before that, it didn't have that. So let's say we want all robots to have this purpose. So by default, if you want every object in a class to have a certain attribute, you can just define it within the class. So right here in this class robot, all we've done is, and you can see previously with just pass, all we've done is added a line where purpose equals to always protect humans. And after we've run this, and this is exactly the same code from before, because we've told it that all robot objects' purpose is going to be to always protect humans, when you now present like my robot.purpose in this next cell, even though, you know, we didn't explicitly say assign this to my robot.purpose, this is automatically there. So since we've defined this class with this purpose line here, all robot objects made after this will automatically have the purpose attribute, which is pretty cool. So what we can do, the thing is these attributes, you can actually overwrite these attributes. So they are not, what's the word? They are destructible. Yeah. So here you can see that we're making a new robot and we are calling the robot lore. And the purpose of the robot is to kill all humans. And because it's using the same robot class from before, where the default purpose is to protect humans, because we've overwritten the purpose here, it actually overwrites with what you set it as. So it's pretty flexible in that sense. So we've made this new robot with the same class, but we've overwritten its purpose to kill all humans. So what you also can do is you can compare your objects. So this code is just comparing to see which robot is taller. And here we are just using these two robots here. Wally was 100, Bob was 2. So what we're doing here, you can actually assign 2 things. 1, you can compare objects. 2, you can assign objects to other variables as well. So here we're assigning tallbot, we're assigning to tallbot, my robot, if the height of my robot is taller than your robot. That's just like another, it's just to show that you can assign tallbot, you can assign to tallbot another object. Also pretty cool. Oh,
question,
yes.
Just quick, can you clean the information in the class at any point in your code?
Can you clean the information in your class?
Meaning,
You mean?
Yeah, like, so if you define all these attributes for the robot, later on, it's like, oh, well, you know what? I want a clean slate with that same robot. Can you, do you need to go all the way back? Because I know you can add in, it seems like you can add in attributes, but can you completely clean the slate with the class at other points in the code?
I think if I'm following what you're asking, if let's say you've created like 5 robots and you realize, hey, I like kind of did something wrong, I maybe want to like get rid of this one attribute, depending on how much code you've already done, it may be easier to just go and edit the specific attribute and like just set it to equals to none or something. Or yeah, maybe you just like rewrite what you wanted to do back in your class and then just rerun your code. It really depends on like where you did more work.
So if you want to change information about the class itself, you need to go back to the actual class.
Yeah, I would say if you think that you need to make like a change that you want to affect all of your objects, it probably will make more sense to just edit your class and just like rerun so that all your objects have this new set of attributes, for example.
Gotcha. Okay.
But it is pretty flexible because instead, let's say I wanted to add not just purpose, but let's say I wanted to do like, I don't know, robot weight. Let's just use that as an example. If I realize I was like weighing everything in pounds, but I actually want to do in kilograms, sometimes it might be easier to just go within each object. Again, it depends on how they're stored, because you can also put like objects in a list rather than, you know, each one to each variable. So yeah, you can edit each object individually or just, you know, rerun the entire class.
Gotcha.
Yeah. Yeah. So where was I? So just really quickly, we looked at what this means. This basically is the hash key for where in your computer's memory the object is being stored. And also to just make sure that objects are not overwriting each other. They're not the same. And I don't know if anyone remembers the difference between the double equal sign and the is operator. I don't know if anyone's remembered that. Anyone? All right, let's do a really quick example.
1 second.
Yeah.
Is it whenever it's pointing to is it whenever it's pointing to the same object? I remember seeing something where it was like arrows pointing and then it moves basically. Am I wrong?
You're on the right. You're on the right path. You're on the right path. So
Okay.
using double equal sign is basically, are they equivalent to each other, right? Like let's say if I had x equals to 5 and y equals to 5, because x equals 5 and y equals to 5, x will be equal to y mathematically, right? So let me just change this. Hopefully I'm right. I'm not sure if this example will come through. There we go. Okay, so typically what it means is, I'm not too sure what example will show that, but typically it means x equals to y. It's more of like a mathematical, are they equivalent to each other? This is asking, are they the same thing? So this is, I'm not sure, I need to think of a different example. I'm probably not going to think of it during this study group, but typically for the is operator, you want it to be stored in the same place in memory.
Would a string be better or no?
Yeah, I think, I'm not sure if that will make, if that'll be different. Let me just check real quick. Yeah, not sure. Back in Mod 1, there's a lab that goes through this. I am personally also a little fuzzy on these logic operators. But yeah, it is good for checking on your objects. But yeah, I won't go more into that. Other questions before I move on to like more attributes. All right, so now we're gonna build on our existing class. So now we can set all of these default attributes. So for example, let's just set the name to be none at first, because we know we can later update it to whatever the robot's name actually is. Material metal is electric true, and number of arms equals to 2, just as like default attributes. So once you run this class, and we're gonna instantiate robot1, and we're just gonna take a look and see what their attributes are. So with robot1, we have the name being none, and basically all of the default attributes are there because we haven't made any changes yet. So we have robot1 having all the default attributes. What we can do is we can edit their names. So what we can do here, we're going to change their name from none to Wally. We're going to add a new attribute to see that if it's solar or not, and it is solar. And then when we reprint that again, and you can see all of these print statements are pulling from robot1, you have all these new attributes. So just to, again, to show like how you can edit objects pretty easily. And again, this will only refer to your own objects, not ones that are created by, like, for example, you won't be able to do this with the data frame because within the data frame, they would have defined methods to stop you from doing that, just so y'all know. All right. So next we're going to talk about class methods, right? Because we've only talked about attributes so far. They're easy to edit. You can change them. You can overwrite existing attributes. But then we haven't talked about methods yet. And methods, you would have to define them as functions. And basically what a class method does is it just acts on an object. So basically here we see that robots have these laws of robotics that we just want them to know. So here we've defined 3 laws of robotics. I won't go into what they say, but we can also define class methods to do something about these laws. So for example, here, what we're gonna do with this print laws method, all it does, it just prints each law of robotics. And then we have this other function that print n law. So we wanna print a specific law. Here, if the number is less than 1 or more than 3, doesn't exist. But if it does exist, you're going to want to print whichever number law it is. So we're just setting up these simple functions to act on these laws of robotics. So on that, here you can see that it actually works on the class itself. Typically, you won't do this. So you can see, oh, actually, just kidding. I'll take that back. If you want to use any of these class methods, you can call in the class robot.function, and you'll get your, it'll just execute the function. So you see here, laws of robotics. One thing that I was curious about is, oh, sorry, right, because this is the attribute, sorry. So laws of robotics is now an attribute. So you call in the attribute, it print out the list. Now, when you're using the methods, you can see here we have the parentheses. So we're print laws, robot.print laws, you're printing out the laws. And then, for example, you're gonna print n law. If we wanna print the second law, this will print the second law. If we give a number that's too big, you can see that it doesn't exist. I think this F string is not working. I think that's what we want to say. There we go. The fifth law doesn't exist. So these are just class methods. So methods that work on the class. So with Wally,
sorry, with the laws of robotics method, you didn't tell it to print. Does it automatically know to print it?
Yeah, so this is pretty much the same thing as what we were doing before when we wanted to call on a specific attribute. So yeah, I misspoke earlier. The laws of robotics is not a method, but it's an attribute, because you see how we're not defining laws of robotics as a function. This is really just an attribute of all the robots, that we just want all the robots to know these laws. Yeah, I misspoke earlier.
Hey, Yish. I see that for the first method that you don't have a return, but for the second one there's a return. Is there, I don't know, I guess, do you have to have a return then?
Yeah, so you can have a return if you want to store information. So if instead of print, I did return law. Wait, let's not do that one, because that one's it's in a for loop. But let's do this one. Right, okay, so if we have this here, and we have print n law, and actually let's not do that one. Let's do, why did the F string go away again? Anyways, let's go do this one and see with the second one. What it does is, it's the same thing. You are returning, basically what the return statement allows you to do is it allows you to store this second law as a variable. So now the second law will be stored as a variable here, versus if we didn't have that, and let me just undo what I just did. That's right? Okay, so this just has the print statement. If I do that now, second doesn't have anything. See,
okay,
because
so it's just like a, oh, sorry. It's just, so it's like a regular, just like a regular function. If you want to return a value out, you use that.
Yep.
Okay.
Because this technically this does print out because it has a print statement, but you're not really assigning anything to second. And yeah, the assignment comes with the return statement.
Okay, gotcha.
Yeah. So really quick, we can also run these class methods on the objects that we create. So here, let's just create Wally to be a robot. He has the laws built in already because, this was defined at the start of the class. Then we can have Wally print the laws as well. Oh, shoot. Can you use them? Oh, that's the next part. Sorry, I misspoke again. So Wally cannot print out the laws yet, because these only work when you call the class name. And I'll explain that comes in the next section. I'll explain why. But yeah, sorry for that. Any questions? I feel like I might have confused some people there. But yeah, when we've instantiated this new robot, again, you can get the attributes the same way, but so far these methods don't work on this object yet. There's something else that we have to do. Question.
And just to be clear, I think you already went over this, but if your class, if you want to change something about a class, you can't just like edit it on the fly. You have to go back to the time you instantiate the class and edit it there, and reload the whole class as something new. Right?
Yeah, if it's a change that you want to keep, for all objects going forward, I probably would edit the class. But if not, then you can still like edit each individual object one by one. But again,
yeah, obviously not the whole class itself. If you want to do the whole class, you have to go back to the original class definition.
That's right.
Okay.
That's right. Okay. So next what we want to talk about is this idea of self. So actually, we're using different examples here, but the same thing follows. So basically, there's two different kinds of methods. class methods and also object methods. So earlier what we had here, these methods that we used acted on the class. So you see, for us to get the print laws and to get the print end laws, we actually called on like robot dot print laws. It's the same thing as when we do df dot something versus something like pd dot to CSV or from CSV. I don't know if that parallel made sense, because sometimes you use your method on the class, sometimes you use your method on the object. So earlier, these methods that we talked about were ones that acted on the class, and now we're going to talk about ones that act on the object. Hopefully that helps to clear things up. So doing something like this, where you see this didn't work, would be akin to doing, let's say I had a data frame and I wanted to do like data frame dot read CSV. And we all know that read CSV is something that works out of pandas, right? We do pd dot read CSV, not df dot read CSV. So that's kind of the difference here. With this example, less straightforward, but basically why this is an error, this is an example of us trying to do data frame dot read CSV when we should be doing pd dot read CSV. All right, so that just goes to a different different type of method, which are methods that work on objects. And all of these have to take in this self reference. So basically, if you want to write a method that works on objects, in the method, you would have to pass in a self argument. And self argument is something that Python classes automatically recognize. So it's a good practice not to call your argument self other than, the actual self one. So what we have here, we have this robot class, and these are the default attributes, and these are going to be object methods. So let's just say we wanted to define this one first, a method that will just have the robot say its name. So what you have to do here is it actually takes in the object as an argument. And then you can see within this function, we're using the attribute to have it say its name. Similar here, you can just have it add numbers, I guess. So here you can see, even though we're not using any of like the self attributes or any of like the object itself within this function, if we wanted to use this as an object method, we would still have to pass in the self argument. So actually later after this, we can go back and see how that looks. So now we have instantiating robot to be Wally. And at the bottom here, as we ask it to speak, it says I am none, which makes sense because we haven't given it a name yet. And then you can also add numbers. So one quick fix to get this method to work on the object that we had before is literally just give it the self argument. So what we do here, I just ran this class. And now when I run this, it should be able to print the logs. Let me just do a quick double check. Speak self. Did I not? Oh, you know why? Because I have to run this as well. There we go. All right, there's a lot of things out of order, but basically the point is, if you want something to be able to run on an object, you need to give it the self argument. Interesting thing, something to note, is that when you are actually using the method, you don't have to give it self. So by default, self is always the first argument within each method. And when you're actually using the method, you don't have to give it self as an argument. So even with these add numbers, you can see that this function takes in 3 arguments, self, num0, num1. You only need to give it the 2 numbers to add up. Questions about this? Cool. So same way, you can just update the attribute here. And let me just make sure that this is the one that we're using. So we'll run this. Update the name and have it speak again. And you can see that now it says Wally. Something that's pretty cool is you can kind of edit the methods within a class. So here you can see right now this is speak. But now we can update speak with a new Lambda function. Again, this is more advanced, so I wouldn't worry about it too much, but basically if you do Wally.speak now, it will perform this Lambda function. Cool. That's all I had to share for object-oriented programming. This really takes a lot of practice. If you are really interested in this side of programming, I do have a bunch of the old Learn lessons that are actually not part of your curriculum that I can share. Or is it in your, it might be in your appendix now. I'm honestly not, I don't remember. Yeah, it might be in your appendix now. So if you're interested, there we go. Yeah, there's a bunch of lessons on object-oriented programming if you want to keep doing that.
Hey, Yish, when you change that method, is it only applying for that object, or is it applying for all the objects in that class?
Ooh, that's a good question. I'm actually not sure myself. So let's create a new one and we'll take a look. So let's see Wally2, and then let's do Wally2.speak. So I guess only the one. Yeah, I guess it only changes the one. Yeah, I personally don't use object-oriented programming that much, so honestly not super familiar with all of these like intricacies. One more thing I wanted to, oh wait, any questions about this stuff? Because I want to talk about some like more potential applications of this. All right, so potential applications of this. Some people for their functions, and I'll walk through again the defining of functions. Some people like to put all of their functions like within maybe 1 or 2 classes. So if you're writing a lot of functions for like data cleaning, maybe you have like a cleaning class. If you have like a transformations, you're doing a lot of like data transformations, maybe create like a transformation class. That's how some people use this. Something else that's a little bit more abstract that might be something worth looking into after graduation is objects can be used with SQL. And it's in something called ORM, which I believe is object, hold on. Let me see if this will give me anything. There we go, object relational mapping. I always forget what it stands for, but object relational mapping is pretty cool. So imagine a SQL table where you have a lot of like many-to-many relationships. So if you have like an employees table, and then like maybe an offices table, for example, you can, if there's a relationship between them, ORMs basically set it up such that they are each other's attributes. So if you were to do like office location 1.employees, you can actually get a list of employee objects where you can like do functions and like figure out what you want from there. It's pretty cool. I don't remember, let me just quickly check to see if it's in any of this. It might be in here, I don't remember. If it's not, I'll send some practice materials out, but basically what we had to do in our mod 1 project was create an object relational mapper, which was awful, but very, very like, it's good to know, I think. I do think it's good to know. So I will send out some material on that. And maybe in the, when we get to capstone, if anyone's interested in doing that, I'm more than happy to like walk through the process of that. But yes, because I wanted to talk about things that are more related to your project. Any questions to close out object-oriented programming? Cool. I do think it is worth like at least getting used to the idea of thinking about like attributes and methods in the context of classes. I will say like as a data scientist, you probably won't have to do a lot of this, but if you're working with other teams, it might come in handy because other teams might work with objects as well. All right, well, now I wanted to talk about like, what can you do with functions that you're writing in your project? So something I've been telling a lot of you is that, you know, with this modeling project, you're gonna be doing a lot of repetitive coding, right? If you don't write functions, you're gonna be doing like a model.predict, you're gonna do like, you know, plot confusion matrix like 10 times, you're gonna be doing like your accuracy score, precision recall F1 a bunch of different times, which is why I've been saying, write a function to do that. So you don't have to like keep printing all your results over and over again. I will say this project that I chose took a long time to run. I'm not gonna rerun the cells, but I have some examples. So ideally what you wanna do is think of like, what are the repetitive processes that you're doing in your project? I think the easiest one to start with is your evaluation metrics, and then just turn that into a function. And after you've tested your function and that it works, put it into a Python file. I'm just quickly doing it here. So this is the same one that I showed you before. I had it in my notebook that I showed you all last week. But all I did was I ported the function into this .py file. You can create this .py file several ways. You can do it through Jupyter Notebook. I mean, if you don't want to worry about using other software, that's what you can do. All you have to do is do it with a text file, and then you can literally just change it to functions to .py, and it automatically turns it into a Python file. You can do it that way. I did it that way because I already had this function written. You can alternatively use like VS Code or Atom or any one of those if you have those already. But all you have to remember to do is port over your function, and also don't forget to also in this script import any of the libraries that you're using. And once you have all of that, and if you didn't import something, you will get an error message later on to tell you. Once you've done that, you can basically import this function from this .py file. So for a lot of you who are defining functions, your notebook won't have space taken up just by functions. So now that I have this and it is saved as functions.py, this is my modeling notebook. All I have to do is import my functions. So when you're importing something from a Python file, it's actually pretty neat. It actually automatically recognizes what Python files are in your directory. So because I named my file functions.py, I can just do from functions import evaluate, because this method is called evaluate. And because I did this, I did it for decision tree. I did evaluate like this. I, for some reason, decided to save it as like a tuple where I can have all of my metrics and my confusion matrix there. Another example was for naive Bayes. Basically did the same thing, called on evaluate, gave it like all of my training and testing data, and I have that all there. Main thing I wanted to show you all is the fact that you can put your functions into a Python file and then just import it here. If you have multiple functions, you could do evaluate, comma, let's say you have another one that's like confusion matrix, and then that would just import 2 functions. Or alternatively, you can just straight up import functions, and you can import functions as fn, for example, if you want to use it as a shorthand, same as using like pandas as PD. If you do it that way, one thing to note is if you want to use the evaluate function, you would do fn.evaluate and then give it all your data. So yeah, missing 6 required, blah, blah, blah. Let me just use this as an example because this one's pretty quick. I would have to do fn.evaluate, and let me just copy all of this over. There we go. So that's how you would import your data. 2 ways. I think I put it in your guidelines. Either import file name as whatever and then use fn.function, or import the function directly so you don't have to call in the name beforehand. Cool. A couple notes that I made for myself to remind you all of. Again, you can put them in Py files, and don't forget to import the libraries that you need. And also, any unknowns need to be inputs. So what I mean by that is in this function, because I actually used this in my notebook before, previously I didn't have these variables because I knew that in my notebook, I had my X train, my Y train all already defined in my notebook. Because these are in a separate script, this X train, or at least this X train, it would come as like X train was not defined, because if we're using this function, X train hadn't been defined yet. So what we're gonna do here is instead, we have to keep track of these variables, which is why I'm adding all of these here. Does that make sense? Basically, the thing is your X train in your script, which is X train here, won't be recognized as your X train in your modeling notebook here. So that's just something to keep track of. Cool. Yeah, I think that's all I had to share for you all. Any questions regarding this?
As far as, oh, sorry, go for it.
I was going to say, if you put it in a folder, I assume you'll have to like tell the path of where to import it from. Like you have to
Absolutely.
Okay.
Yep. So let's say you have like a folder here, maybe from scripts. Oh, the difference is it would be scripts.functions. Yeah, that's one thing that you have to remember. If you have it in a folder, maybe your folder is called scripts, you do from scripts.functions, import that. But yeah, instead of doing the slash, you have to use a period to denote like your file path.
And what if you need to go up a directory?
If you need to go up a directory, that, honestly, I'm not too sure. I've never had to do that. I will look into it for you because I'm not too sure.
You can do a squiggle and it'll take you to your home directory.
That sounds about right. Yeah.
Or something. You could do something to make it go straight from your home directory and then you can go down.
Yeah, there's some, yeah, along those lines. There's some weird symbols. I'll look it up and I'll send it out from outer directory. Yeah, I'll make a note of that to look that up. But yes. Anything else? Any other questions? Cool. Well, since, you know, this is like the start of like the project phase, anyone have any like project related questions that I can help answer?
I don't have a project one, but just in general about the object-oriented programming.
Mm-hmm.
So is this like something that is desired in industry at all? Or is this like something that we should put a lot of time into, or?
Mm-hmm. So my experience teaching on campus, we've actually cut that whole section out of the curriculum on campus and no one has been asked about it. I will say it is just good to know because it sort of gives you an insight into like how methods and attributes are working, even with like, you know, like that pandas example. I feel like it sheds more light on how those work. But as a data scientist, you almost never have to work with objects because it is an interesting way of storing data, but we just store our data in like data frames or in like dictionaries, which is for our purposes easier to work with. But yeah, good to know. But I haven't heard of any student being asked an OOP question in an interview.
Okay, cool.
Yeah. Anything else? Cool. Well, as I mentioned towards the start, my other core is getting their project this Thursday. So I'll like put you all into groups. Actually, I'm just gonna put you all into groups first and just add them to the channel as they decide on their data set. So I think that would be useful. Just say hi. I mean, everyone here is friendly. I have had one-on-ones with all of you. So I'm sure that you will all get along and have like very different perspectives to share for sure. So just look out for that. Next office hours, I was planning to talk a little bit about presentation for this and what it would look like. I don't know if anyone has any suggestions or like anything that like, I guess in the next couple of days, if you come across anything, just let me know and I can definitely incorporate that into our office hours because I feel like a lot of the stuff is quite similar to the last project. So yeah, I was just planning on taking questions, but happy to like focus in on certain things if requested. All right, any final questions to close out? All right, going once, going twice. All right then, well, everyone have a good rest of your night. I'll see you all at your one-on-ones. Any questions, again, feel free to always just Slack me. All right, good night, everybody.